grade 3 secondary. Welcome to our program today. Today we have calculus. Our lesson today is the derivative of the exponential function and the logarithmic function. Rule. Derivative of the natural exponential function. If the function f of x equals e to the power x, then f dash x, or the first derivative of the function e power x, equals e to the power x. And we can write this rule as d e power x by dx equals e to the power x. In general, chain rule, if z is a differentiable function of x and f of z equals e to the power z, then the derivative of e to the power z with respect to x equals e to the power z multiply dz dx by using chain rule. Let's start with the first example. If f of x equals e to the power 2x, find f dash x. F of x equals e to the power 2x, then the first derivative of the function f dash x equals e to the power 2x multiply the derivative of the power. The derivative of 2x equals 2, then f dash x equals 2 multiply e power 2x. Another example, if f of x equals e to the power x power 2, find f dash x. The function f of x equals e to the power quadratic function x power 2, then f dash x equals e power x power 2 multiply the derivative of the power. The derivative of x power 2 is 2x, then f dash x equals 2x multiply e to the power x power 2. Another example, if f of x equals e to the power 3x power 5, find f dash x. The function f of x equals e to the power 3x to the power 5, then the derivative of the function f dash x equals e to the power 3x power 5 multiply the derivative of the power. Derivative of 3x power 5 equals 15x power 4. Then f dash x equals 15x power 4 multiply e to the power 3x to the power 5. Now we move to the next example. If the function f of x equals e to the power 10x, find f dash x. F of x equals e to the power trigonometric function, e to the power 10, then f dash x equals e to the power 10 multiply the derivative of 10x. The derivative of 10x equals sec power 2x. Then f dash x equals sec power 2x multiply e to the power 10x. Another example, if y equals e to the power x over 10x, find dy dx. Now we have a quotient. Y equals e to the power x divided 10x. We can use the derivative of quotient of two functions. Dy dx equals 10x, which is the function in the denominator, multiply the derivative of the function in numerator. 10x multiply the derivative of e to the power x dx by dx, minus the function in numerator e to the power x multiply the derivative of the function in the denominator, which is 10x. all over tan x all to the power 2. Then dy dx equals tan x times derivative of e to the power x is e to the power x minus e to the power x multiply the derivative of tan x. Derivative of tan x equals sec power 2x all over tan x all power 2. We can take e to the power x as a common factor. Then dy dx equals e to the power x multiply between two brackets tan x minus sec power 2x all over tan power 2x. We can write tan x all power 2 as tan power 2x. Another example, if the function f of x equals sec e power x, find f dash x. The function f of x equal trigonometric functions sec e power x. The angle is exponential function e to the power x. Then f dash x equals the derivative of sec e power x, which equals sec tan. Sec e to the power x tan e to the power x times the derivative of the angle, derivative of e to the power x by x, or with respect to x. Then f dash x equals e to the power x, which is the derivative of e power x, multiply sec e power x tan e power x. Now we move to the next example. If x equals e to the power 2t and y equals t to the power 3, find dy dx. Now we have a parametric differentiation. When x equals e to the power 2t, then dx dt equals e power 2t multiply the derivative of the power. Derivative of 2t equals 2, then dx dt equals 2 e power 2t. And y equal t to the power 3, then dy dt equals 3t to the power 2. Now dy dx equals dy dt times dt dx by using chain rule, or dy dx equals dy dt divided dx dt by using parametric differentiation rule. Then dy dx equals 3t power 2 divided 2e power 2t, which is the derivative of y with respect to x. Now we can deduce the following rule. Derivative of exponential function to the base a. If the function f of x equals a to the power x, where a is any real number, then f dash x equals a to the power x ln a. A bigger than 0 because ln a is appear in the rule. We know that a equals e to the power ln a from the logarithmic properties. Then a to the power x equals e to the power ln a all to the power x. A to the power x equals e to the power x multiply ln a. The derivative of a to the power x with respect to x equals the derivative of e to the power x ln a. Derivative of e to the power x ln a equals e power x ln a multiply the derivative of the power. Derivative of x ln a equals ln a. Then the derivative of a power x with respect to x equals a to the power x multiply ln a. In general, chain rule, if z is a differentiable function of x, and f of z equals a to the power z, then the derivative of a power z with respect to x equals a power z multiply ln a dz by dx. Now we move to the next example. If f of x equals 3 to the power x, find f dash x. The function f of x equal 3 to the power x. The base is a constant, a real number not equals e. Then the derivative f dash x equals 3 to the power x multiply ln 3, ln the base of the function. Another example. If f of x equals 7 to the power x minus 1 all to the power negative 2, find f dash x. The function f of x equals 7 power x minus 1 all power negative 2 means the power x minus 1 multiply negative 2. Then the function f of x equals 7 to the power negative 2x plus 2. Now, what is the derivative of 7 to the power negative 2x plus 2? F dash x equals 7 to the power negative 2x plus 2 multiply the derivative of the power, which is negative 2 multiply ln 7. Now we move to the next example. If f of x equals 5 to the power x power 3 plus 2x, find f dash x. F of x equals 5 to the power x power 3 plus 2x. Then the derivative of this function is 5 to the power x power 3 plus 2x multiply ln 5 multiply the derivative of the power. What is the derivative of x power 3 plus 2x? Yes, the derivative of x power 3 plus 2x is 3x power 2 plus 2. Then the derivative of the function 5 to the power x power 3 plus 2x is 5 to the power x power 3 plus 2x multiply between two brackets 3x power 2 plus 2 multiply ln 5. Students, we can deduce the following rule. Derivative of natural logarithm function. If f of x equals ln x, where x bigger than 0, then the derivative of this function f dash x equals 1 over x. We note that the logarithmic function is an inverse function of the exponential function. Then if y equals ln x, then x equals e to the power y. By differentiating both sides with respect to the variable x, then derivative of x equals 1, and the derivative of e to the power y with respect to y is e to the power y dy dx. And we know that e to the power y equal x, then 1 equals x dy dx. Then dy dx equals 1 over x, and we can use this rule to find the first derivative of the function f of x equals ln x. In general, chain rule, if z is a differentiable function with respect to the variable x, and f of z equals ln z, then the derivative of ln z by dx equals 1 over z multiply dz by dx. And if x smaller than 0, then the derivative of ln negative x with respect to x equals 1 over negative x multiply negative 1, which equals the same result, 1 over x. In general, the derivative of ln absolute x with respect to the variable x equals 1 over x for each x doesn't equal 0. And the derivative of ln absolute z with respect to z equals z dash over z, where z is a differentiable function at x. Now we move to the next example. If f of x equals 2 ln x, find f dash x. F of x equals 2 ln x, then f dash x equals 2 is a coefficient. 2 multiply the derivative of ln x equals 1 over x. Then f dash x equals 2 over x. Another example. If the function f of x equals ln between two brackets 2x minus 7, find f dash x. The function f of x equals ln 2x minus 7, then f dash x equals 1 over 2x minus 7 multiply 2. 1 over the function of the ln of the number behind ln multiply the derivative of 2x minus 7, which equals 2. Then f dash x equals 2 over 2x minus 7. Another example. If the function f of x equals ln 3x power 4 plus 8, find f dash x. F of x equals ln between two brackets 3x power 4 plus 8, then f dash x equals 1 over 3x power 4 plus 8 multiply the derivative of 3x power 4 plus 8, which equals 12x power 3. Then f dash x equals 12x power 3 over 3x power 4 plus 8. Now we move to the next example. If the function f of x equals ln 1 over x power 2 plus 9, find f dash x. We know that ln 1 over x power 2 plus 9 can be written as ln x power 2 plus 9 all to the power negative 1. And from the properties of logarithm, we can write f of x equals negative 1 multiply ln x power 2 plus 9. Now, what is the derivative of negative ln x power 2 plus 9? The derivative f dash equals negative 1 over the function x power 2 plus 9 multiply the derivative of x power 2 plus 9, which is 2x. Then f dash x equals negative 2x over x power 2 plus 9. Dear students, we can deduce the following rule. Derivative of logarithmic function to the base a. If f of x equals log x to the base a, where x bigger than 0, then the derivative of the function f dash x equals 1 over x multiply ln a. A is the base of the logarithm. 1 over x ln a equal 1 over x log e to the base a. Now, if we have log x to the base a equals ln x over ln a, then the derivative of log x to the base a with respect to the variable x equal the derivative of ln x over ln a with respect to x. Then the derivative equals 1 over ln a as a constant times the derivative of ln x with respect to x. The derivative of ln x with respect to x equals 1 over x. then the derivative equals 1 over x multiply 1 over ln a, which can be written as 1 over x log e to the base a. In general, from chain rule, if z is a differentiable function of x and f of z equals ln z, then the derivative of log z to the base a with respect to x equals 1 over z ln a multiply dz dx equals 1 over z log e to the base a multiply the derivative of z with respect to x. Now we move to the next example. If f of x equals log x to the base 4, find f dash x. The function f of x equals log x to the base 4, then f dash x equals 1 over x multiply ln 4. 4 is the base of the logarithm. Then f dash x equals 1 over x log e to the base 4. Another example. If f of x equals log 4x power 2 minus 1 all to the power 3, find f dash x. F of x equal log between two bracket 4x power 2 minus 1 all to the power 3. From the properties of logarithm, we can write this function f dash x equals 1 over 4x power 2 minus 1 all to the power 3 ln a multiply the derivative of the bracket. The derivative of the bracket 4x power 2 minus 1 all power 3 is 3 multiply the bracket 4x power 2 minus 1 all to the power 2. Multiply the derivative of the function inside the bracket. The function inside the bracket 4x power 2 minus 1, the derivative of this function is 8x. Then f dash x equals 24x all over 4x power 2 minus 1 multiply ln 10. Another example. If f of x equals log absolute sine x, find f dash x. The function f of x equals log absolute sine x, then the derivative of the function f dash equals 1 over sine x multiply ln 10. 10 is the base of the log, multiply the derivative of sine x, which is cosine x. F dash x equal 1 over sine x ln 10 multiply cosine x. Then f dash x equals cosine x over sine x equals cotan x over ln 10, and we can write f dash equals cotan x multiply log e to the base 10. Another example. If f of x equals log e to the power x power 2 over x power 2, find f dash x. The function f of x equals log e power x power 2 over x power 2. We can write this function as log e power x power 2 minus log x power 2 from the properties of logarithm. And now we have a difference between two functions. F dash x equals derivative of the first function, which is log e to the power x power 2. The derivative of log e to the power x power 2 is e power x power 2 times 2x, which is the derivative of the function, over the function e power x power 2 multiply ln 10, which is the base of the logarithm, minus derivative of x power 2, which is 2x over x power 2 multiply ln 10. Then f dash x equals 2x multiply log e minus 2 over x multiply log e. Then f dash x equals 2 log e multiply x minus 1 over x. Now we can deduce the following rule: logarithmic differentiation. The relation among the variables can be expressed in a logarithmic form by taking of the natural logarithm of its both sides and using the properties of logarithms to simplify the relation before doing the differentiation operations. Example: find divisor dx for y equals x to the power 2x. Y equal x to the power 2x by taking the natural logarithm of both sides of the relation. Then ln y equals ln x to the power 2x. Ln y equals x ln x to the power 2x, and we know that ln x power n equals n ln x. Then ln y equals 2x ln x. By differentiating both sides of the relation with respect to the variable x, the derivative of ln y by dx equals derivative of 2x ln x by dx. Now, derivative of ln y equals 2x multiply derivative of ln x by dx plus derivative of 2x by dx times ln x. Derivative of ln y equals 1 over y dy dx equals 2x times derivative of ln x, which equals 1 over x, plus 2, which is the derivative of 2x times ln x. Then 1 over y dy dx equals 2 plus 2 sine x, and dy dx equals x to the power 2x multiply 2 plus 2 ln x, and we can take 2 as a common factor. Then dy dx equals 2 multiply 2x power 2x multiply between two bracket 1 plus ln x. And by this example we come to the end of our program today. Until we meet again, it's goodbye.